Hi, everyone. All right, so a few things before we really get started into this lesson. If you at all want to do the Desmos lesson for this, the balancing equations lesson, feel free to do that. After you finish that, you may or may not still need these videos. These videos are just completely for support if you did not get out of it what you thought you needed to. Hopefully these videos still will be pretty short and sweet, so that way you're not wasting a ton of time if you're watching both and doing the Desmos lesson. Either way, here we go. We're going to be solving special systems. If you remember when we were looking at solving special linear equations, we were looking at situations where we would get or like we would get answers of like 0 equals 21 or 0 equals 0, and the variables would completely eliminate themselves. Well, we're going to be doing that same sort of idea, except this time we are looking at two equations and we need to figure out where these two equations intersect. They may or may not actually have an intersection point. What we'll find is during these special systems, there's 3 different scenarios. So let's look at one of those scenarios. So those 3 different scenarios, we're going to figure out solutions that look in like 3 different things. And we'll sort of just keep a tally. So here's our first system that we're going to look at. We have x is equal to, or y is equal to x minus 1 and negative x plus y equals 2. We're going to solve this. We can do it in any way, shape, or form you want to. We can do it with elimination or substitution or whatever else. I am going to do substitution because that's my jam. I really like substitution. I'm pretty good at it. I don't know, but when I was in 8th grade math, I killed it with substitution, but when it came to elimination, I would regularly get myself pretty confused. That doesn't necessarily happen to me anymore. I'm pretty fluent in elimination as well now, but at the same time, like elimination was a little tricky for me. So what I just did just now is I set both of these, or I took this second equation where it was not already set for y and set it equal to y. So now I have one equation set, or both equations are now set equal to y. So now I can say, okay, let's cut out the middleman of y and just say x minus 1 is equal to x plus 2. And so we will solve this. First of all, hopefully you're already screaming, or maybe you are, or maybe you've noticed this, I don't know. Maybe you're saying, okay, we have x on both sides, but we have 2 different constants. That's a problem. That's a problem. If these 2 things are equal to each other and these x's both represent the same thing, I now have those situations. You guys remember them from our linear equation stuff, where essentially if I were to map this out, I essentially have a box that is equal to x, and then like we've taken maybe a coconut out of it or something like that, taken something out of it. We've subtracted that one something from it, and we're comparing that to this other box here. And we have that same box x, and we have 2 of these coconuts. So we're saying a box with one of these things taken out is equal to that same box with 2 more things added to it. And we're saying those are equal. Are they? No. They are not even the least. So let's actually prove it to ourselves with the numbers themselves. Let's subtract x from both sides so we can combine the like terms. So x minus x is equal to 0 x's, so I get negative 1 is left over on this side. And over here, x minus x also cancels out, so I have 2 left over here. So I now have negative 1 is equal to 2, which is a false statement. Not even on Pluto does negative 1 equals 2. So this system is like broken, right? So let's understand what the system truly looks like so we can really get it. If I were to graph this system, it would look something like this. This first one, y equals x minus 1. I'm going to start at negative 1. Sorry, I have my little dots on here that you can't necessarily see that help me graph. All right, so y equals x minus 1. So I'm going to start at negative 1. I have a slope of 1, essentially. So up 1 over 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And I have this down 1 to the left 1. I have this line that I can draw. Cool. This second one, y equals x plus 2, I am starting here, and I have that same slope of 1. So I'm going up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, down 1 to the left 1, down 1 to the left 1. And I have just created a set of parallel lines, which hopefully you remember when we were looking at parallel lines and looking at slopes and y-intercepts and that sort of thing, when we were doing our linear equations module, we now can see that these two lines are never going to intersect, ever. So one option for special systems are systems with no solution. And what we can say with those special systems, these no solution systems are essentially parallel lines. So they're never going to intersect. It's never going to work out. So when you're solving special systems, solve it, use elimination, use graphing, use substitution. I don't care. Figure out, do you get an answer like this? Or do you have two lines that never intersect? Are they parallel? And then you are good to go. We have 3 more videos. At least 2 more videos, maybe 3 more videos. Sorry, I'm still planning out the last end of the back end of this lesson. We at least have 2 more videos, and we are going to look at 2 more situations for special systems. Thank you for watching, and I will see you on the flip side. Bye.